So this lesson is a review of how to multiply polynomials. And what we're going to do is start with a numerical problem just to get your brain back into what it means to use the area model. So what I'm going to do is break 12 down into 10 plus 2. And I'm going to do the same thing with 15. So this is 10 plus 5. And then what I'm going to do is create a rectangle with side lengths that are 10 plus 2 and 10 plus 5. And I'm going to break down this box or rectangle into separate pieces, smaller pieces, that represent a side length of 10, 10, 2, or 5. So now I'm going to multiply and find the area of each of these individual pieces. So this would be 100 because 10 times 10 is 100. Here I'm going to multiply 2 times 10, and this would be 20. Here I'm going to do 10 times 5, so this would be 50. And then 2 times 5, which gives me 10. So now I'm going to start adding these all up. I have 100 plus 50 plus 20 plus 10. So this would be 150, 170, 180. And we can do the exact same thing if we're looking at polynomials. So now we're going to look at x plus 2 and x plus 5. And I'm going to do the exact same thing. I'm just replacing the tens with an x. So I'm going to create another box. And I'm going to put x plus 2 and x plus 5 on both sides. And it doesn't matter which one you choose, your first binomial or your second. It's going to end up giving you the same thing. So I'm going to separate these down into smaller boxes. So I have x times x, which gives me x squared, x times 2, which gives me 2x, x times 5, which gives me 5x, and then 5 times 2 gives me 10. Now, because these are not all numbers and variables are involved, I have to only combine things that are like terms, so things that look the same. So I can put 2x and 5x together because they both have an exponent of 1 on their variable. I can't combine it here because the exponent is 2. So my final answer would be x squared plus 7x plus 10. So if I'm looking at the standard form of different types of polynomials, we always want our highest exponent to be first. So if it was a quadratic, I could have x squared minus 5x plus 7. That would be an acceptable way to write standard form of a polynomial that is quadratic because x squared is first, followed by x, followed by the constant. So you want to have your variables go from highest exponent down to lowest exponent. So if it was cubic, my first would have to be x cubed, and there can be a coefficient in front of that. That's not going to change anything. It just has to be the highest exponent first. And it is also possible that you may not have a variable with the exponents of 3, 2, and 1. But if it's cubic, I have to make sure that the x cubed goes first. We could also see just x cubed plus a constant. This still counts as a cubic function because my highest exponent is 3, and this is still standard form because x cubed is first. Same thing with quartic. highest exponent has to go first, then whatever is lower, and so on. Again, I don't have to have every exponent represented, but I have to make sure that they are in descending order, highest to lowest. So what if we now have a binomial multiplied by a trinomial? 2 terms times 3 terms. I'm still going to do a box. However, it's just going to have more pieces when I break it down into smaller sections. So I'm going to put x plus 2, and then I'll have x squared minus 3x plus 5. So my camera will catch up in a second. So the only difference is, instead of having a 2 by 2, we now have a 2 by 3. It's the exact same process. Nothing has changed other than I have an extra column or an extra row because it could be turned the other way. Still the exact same thing. So I'm going to go through and multiply. So I have x times x squared, which gives me x cubed. 2 times x squared gives me 2x squared. X times negative 3x gives me negative 3x squared. These two multiplied together will give me negative 6x. Here I'm going to have 5x and then 10. So again, I'm now at the point where I'm looking for like terms, and if the variable does not have the same exponent, it cannot be combined with any other variables. So x cubed is the only one of that exponent, so that's going to be my first term because it is the highest exponent I see. Then I'm going to look at my x squared terms. 2 minus 3 gives me negative 1x squared. Negative 6x plus 5x is going to give me negative x, and then plus 10. So this would be called a cubic polynomial because the highest degree is 3. It's a polynomial because there is more than 3 terms. So another option is to do distribution. I don't teach this in Math 1 because if you're not super careful, it is possible to miss pieces. What I'm doing is taking each term in this first set of parentheses and multiplying it by every term in the second set of parentheses. So I'm doing x times x squared, which gives me x cubed. And then I'm doing x times negative 3x, which gives me negative 3x squared. Then I have to do x times 5, which gives me 5x. Now I have multiplied x by all 3 terms in the second set of parentheses. Going to do the same thing with 2. It needs to go to every single term and get multiplied with those 3 terms. So I'll have 2x squared minus 6x plus 5. And now I need to combine like terms. There's nothing that will combine with x cubed, so that will be first. I have 3x squared, negative 3x squared and positive 2x. So negative x squared, 5x, negative 6x, and then plus 5. So again, the exact same answer, different method. At this point, now that we're in Math 2, you are welcome to do any method that you choose. So, missing a parentheses. So here's an example. You can either do distribution or the box method, whichever you prefer. And I'm going to just pause a second so you can pause the video and then come back and check your answer. So I'm going to do the distribution method since that's new. X times x squared gives me x cubed. x times negative x gives me negative x squared, and then finally x times negative 3 gives me negative 3x. And if you did the box method when you paused the video to try this, you should still see these terms show up in your box with the corresponding pieces that have a side length of x and a side length of x squared, or negative x, or negative 3. So 5 times x squared gives me 5x squared. 5 times negative x gives me negative 5x, and 5 times negative 3 gives me negative 15. So now I'm back to combining like terms. Nobody goes with x cubed. And then I have 5x squared and negative x, so that will give me plus 4x squared. Combining my x terms will give me negative 8x, and then nobody has another constant, so it will just be minus 15. So again, this is called a cubic polynomial because there are more than 3 terms. Here's another one. Now, I'm going to scoot this up a little bit. If you are choosing to do the distribution method, that's fine. You need to pick 2 of the parentheses and multiply them together first. Then you'll create a statement with another set of parentheses with whatever this has multiplied to be, and that. If you're doing the box method, you're going to do the box twice. You're going to do the box with 2 of them, get your answer, and then do a box with your answer from the first portion and this. So, personally, I'm going to do the distribution method first and then the box method second, just so you see both ways. So doing distribution first, I've got x times x, which gives me x squared, x times negative 2, which gives me negative 2x. Now I've done everything that I need to with this first term and my second set of parentheses, so now I'm going to move on to 2. 2 times x gives me plus 2x, and this gives me minus 4. Again, if you did the box method for this, you should see the same thing show up. When I combine like terms, these 2 will cancel out to 0, so I will not have a linear term. I'll just have x squared minus 4. But we didn't use this third parentheses yet, so I have to remember that I'm doing that last. So again, I'm going to show you the box method just so we see both of these again to help your brain. So I've got x squared minus 4 and x plus 3. X squared times x gives me x cubed. X squared times 3 gives me 3x squared. X times negative 4 is negative 4x, and negative 4 times 3 is negative 12. So my final answer becomes x cubed plus 3x squared minus 4x minus 12. And again, that is a cubic polynomial because the highest exponent is 3. This would be a quadratic binomial. Quadratic because that's the highest exponent. Binomial because there's 2 terms. This is a linear binomial because the highest exponent is 1 and there's 2 terms. So the next example we have, of course my camera froze. The next example is starting to work us into word problems. So now we've been given a rectangular figure and our goal is to find the area. You could split this and do the box method, or you could do double distribution. Either one doesn't matter. Go ahead and pause your video and come back and double check your answer at the end. So here I've got 10x squared. 5x times negative 3 gives me negative 15x. 8x and negative 12. Again, if you did double distribution here, you should get the exact same terms. So 5x times 2 gives me 10x squared. 5 times negative 3 gives me negative 15x. 4 times 2x gives me plus 8x. And then minus 12. So at this point, I am going to combine like terms. The only thing I have, regardless of which way you chose to multiply, is those two linear terms. So my resulting polynomial is actually a trinomial in this case because there are 3 terms. It is quadratic because the highest exponent is 2. Now what if you were given 5x minus 3 squared? This does not mean that I am applying the squared to this term and to that term. What this means is I'm actually multiplying this by itself. Because if you remember, when we first started learning about what exponents mean, if I saw something like 5 squared, that meant I was doing 5 times 5. Now, what I've done is I've changed this piece inside of the parentheses that I put around 5. I've changed that from 5 to now a binomial. It does not change this principle. So now, again, I'm back to the same thing we were doing before. You could choose the box method. You could choose to do distribution. It does not matter. Just in the essence of time, I'm going to do distribution. So 5x times 5x gives me 25x squared. 5x times negative 3 gives me negative 15x. Negative 3 times 5x gives me another negative 15x. And then negative 3 times negative 3 gives me plus 9. So here, negative 15x plus another negative 15x is going to give me negative 30x. So my resulting polynomial will be a quadratic trinomial, 25x squared minus 30x plus 9. Everyone's favorite word problems. So Farmer John is creating a rectangular garden where the length is 7 feet longer than the width. Write an expression to represent the area of the garden. Because I see area, I know I'm going to be doing multiplication. It's a rectangular field. Those of you that had me in Math 1 know how much I love drawing pictures with my horrible art skills. So the width is how I have expressed the length, which tells me the width is where I'm going to define x. And then the length is 7 feet longer, so that will be x plus 7. You can do the box method, always an option. You could also choose to rewrite it like this and distribute x to both pieces. Either way, you're going to end up with the exact same answer, which will be x squared plus 7x. Did a very terrible job printing that. So this side here is x. This bottom sign is x plus 7. Apparently my printer just wasn't feeling like working very well with me today. So our goal is to find the area of the shaded region. So we have this large rectangle, and really what we've done is cut this little rectangle out of it. So if I know the area for the entire picture, I can take away the area of this small rectangle, and that will give me what has been shaded as my leftovers. So again, you can do distribution, you can do the box method. I'm going to do distribution only because for me, it's a little bit faster. I know it's the exact same thing. Just pretend that it's so 5x times 3x gives me 15x squared minus 5x. Here I'm going to get plus 6x, and here I'm going to get minus 2. Combining these will give me 15x squared plus x minus 2. Now you will notice they were nice. These are the length and the width that we had from our farmer question right before. So I know when I did this multiplication, I got x squared plus 7x. So now our job is to subtract this portion from this portion. You can choose to write this any way you want. I'm going to turn my paper sideways so I have more room. So I have 15x squared plus x minus 2. And I'm going to subtract x squared and subtract 7x. So what I'm doing is distributing that negative. So I have 15x squared plus x minus 2 minus x squared minus 7x. So 15 minus 1 gives me 14x squared. I have x minus 7x, which gives me negative 6x, and then my constant remains the same. So that would be the area of the shaded region. All right, last but not least, area of this figure. They were nice. They gave us the area of the area formula, excuse me. So the first thing I have to do is add the two bases together. So I have x minus 3 plus x plus 7. In this case, the parentheses really aren't going to matter because I'm adding, I'm not subtracting. So I have x plus x, which gives me 2x, and negative 3 and 7, which gives me plus 4. So my area formula is 1/2 times the height times the bases added together. Well, I did that already. I have 2x plus 4. The height is 4. Now you can go about this in a variety of different ways. Personally, seeing 1/2 times 4 is the first thing that I would choose to do. You could distribute the 4 to both of these terms. You could distribute the 1/2 to both of these terms. I'm just going to knock out the fraction right off the bat. So that would give me 2 times 2x plus 4, which as a result will give me 4x plus 8. And that would be the area of that trapezoid. Last but not least, floor of a rectangular cage has a length 4 feet greater than its width. So I'm going to start by drawing a picture of the original. And I'm going to label it original so I don't get confused. Its width is W. Its length is 4 feet greater, so that would be W plus 4. Now he's going to increase both dimensions of the floor by 2 feet. So that means the width and the length are both getting bigger by 2 feet. So my new one is W plus 2, because I've increased this by 2. Now I have to increase this by 2. So W plus 4 plus 2, which is really W plus 6. So this will be my new area, and this is what I need to calculate. You can do the box method, you can just do distribution, it does not matter. So I have W times W, which gives me W squared, W times 6, which gives me 6W, 2 times W gives me 2W, and 2 times 6 gives me 12. So I have W squared plus 8W plus 12. And that is the formula, or the expression, excuse me, for our new area. Oh, and they wanted an equation. So, because this is my new area, n equals, to make it an equation and not an expression.